This is the 2019 MEXT Undergraduate Mathematics B paper. Let's begin. Section 1, Number 1. We need to find the number of positive divisors of this number, 2019. 2019 is 3 times 673, so this number can be divided by 1, 3, 673, 2019 itself. So there are 4 positive divisors, and the sum of these divisors is 2696. Section 1, Number 2. In this question, we need to find the equation of the angle bisector of the angle AOB, that is, the equation of this green line. First of all, let's call this point C. And now we have 2 triangles, OAC and OBC. And next, let's use the cosine rule to express the angle AOC and the angle BOC. So let's start with angle AOC. We know that the length of OA is 3, so OA squared is 9. And we don't know the length of OC, and we also don't know the length of AC. And next, let's consider the angle BOC. Now, what is the length of OB? We can calculate it using the Pythagorean theorem. OB is 5. 2 times 5 is 10. BC is AB minus AC. The length of AB is 4, so BC is 4 minus AC. So BC squared is 4 minus AC squared. And since these 2 angles are equal, this must be equal to this. So let's multiply both sides by 30 OC. Now, we can also express OC in terms of AC using the Pythagorean theorem. So OC squared is 9 plus AC squared. The length of AC is 3/2. So the slope of the angle bisector will be a half, and the angle bisector goes through the origin, which means that the y-intercept is 0. Therefore, the equation of the angle bisector is y equals 1/2 times x. And this is the final answer. Section 1, Number 3. In this question, we need to find the equation of a tangent to the parabola, which is parallel to the line that goes through points A and B. So let's draw a quick sketch of the graph. Since these 2 lines are parallel to each other, let's figure out the slope of the segment AB. So the slope of these 2 lines must be 2. Next, let's differentiate the equation of the parabola, and dy dx needs to be equal to 2. Therefore, 2x is 2. At this point, where the x-coordinate is 1, and the y-coordinate is also 1, the slope of the tangent that goes through this point will be 2. So what is the equation of a straight line that goes through the point 1, 1 with the slope of 2? This is the equation of the blue line, and this is the final answer. Section 1, number 4. In this question, we are told that the line represented by this equation intersects this circle, and we need to find the maximum value of m and the value of r. So first of all, what does the graph of the circle look like? The center of the circle is the origin, and its radius is r. How about the graph of this linear equation? Notice that this equation is in the point-slope form, which looks like this, and the point x sub 1, y sub 1 is called the known point, and no matter what the value of m may be, this line will always go through the known point. So in this case, the known point is 5 and 3. So this straight line will always go through the point 5, 3. But at this stage, we don't know where that point lies in relation to the circle. So let us first of all consider the case where m is 0. When m is 0, y is 3. And this is a horizontal line. And this line has to either touch or intersect the circle. This horizontal line touches the circle instead of intersecting it. And this line goes through the point 5, 3. And as the value of m increases, the slope of this straight line will move like this. So what this means is that basically we need to find the value of m where this line touches the circle like this. So based on this information, we know that the radius r must be 3, because that's the value of r where the horizontal line y equals 3 is tangent to the circle. When two lines that share a common point are tangent to a circle, the distance here and here must be equal. And we know that the distance here is 5. Therefore, the distance between the point of tangency here and the point 5, 3 is also 5. So we can imagine another circle that goes through these 2 points and whose center is the point 5, 3. So let's find the equation of this green circle, and let's move 25 to the left-hand side. And recall that the equation of the original circle was this, because we now know the radius is 3. So likewise, let's move 9 to the left-hand side. To find the intersections of these two circles, let these two equations be equal to each other, and then solve the equation for x and y. I'll skip the intermediate steps, which you can figure out on your own. To find the corresponding y value, let's substitute this value of x into the equation of the original circle. Once again, this is going to be a very long and tedious calculation. I'll skip the intermediate steps. The first value of y corresponds to the first point of intersection here. So we are only interested in this other value. To find the corresponding x value, let's substitute this value of y into this equation. This is equal to 45 over 17. 45 over 17, minus 24 over 17. So we can substitute these values into the equation of the straight line to find the maximum value of m. And the answer is 15 over 8. The maximum value of m is 15 over 8, and the radius r is 3. Section 1, number 5. we need to find the maximum and minimum values of sine x plus cosine x. So let us first of all differentiate this expression with respect to x. The derivative of sine x is cosine x, and the derivative of cosine x is minus sine x. And let this be equal to 0. This means cosine x is equal to sine x. In this domain of x, sine and cosine have the same value when x is pi over 4. And we can find the other values of x where sine and cosine are equal by adding and subtracting pi. Pi over 4 plus pi is 5 pi over 4. Pi over 4 minus pi is minus 3 pi over 4. These two values are outside the domain of x. So of these two values, let's see which one is closer to the outer bound of this domain. So what is the distance between this and pi over 2? The distance is 3 pi over 4. And what is the distance between this point and minus pi over 2? So we know that minus 3 pi over 4 is closer to minus pi over 2 than 5 pi over 4 is to pi over 2. This is the domain of x we are concerned with. And let's say 5 pi over 4 lies here. The distance between these 2 points is greater than the distance between minus pi over 2 and minus 3 pi over 4 here. So remember that the maximum value lies at x equals pi over 4 and the minimum value here and here, like this, which means that the minimum value inside this domain should be here instead of here. So what is sine pi over 4 plus cosine pi over 4? Sine pi over 4 is root 2 over 2, and cosine pi over 4 is also root 2 over 2. So this is equal to root 2. And what is sine minus pi over 2 and cosine minus pi over 2? Sine minus pi over 2 is minus 1, and cosine minus pi over 2 is 0. So this is minus 1. Therefore, the maximum value is root 2, and the minimum value is minus 1. Section 1, number 6. In this question, we are given two approximations, and we need to find how many digits this number has, as well as its leading digit. From the first approximation, we know that 2 is about 10 to the power of 0.3010. Likewise, 3 is about 10 to the power of 0.4771, and 6 is 2 times 3, which is 10 to the power of 0.3010 times 10 to the power of 0.4771, which is 0.3010 plus 0.4771, because 10 to the power of A times 10 to the power of B is 10 to the power of A plus B. So 6 is about 0.7781. So what is 6 to the power of 100? 6 can be replaced with this, and recall that 10 to the power of a to the power of b is 10 to the power of a times b. Therefore, this is 10 to the power of 77.81. So how many digits does this number have? 10 has 2 digits. 10 to the power of 2, which is 100, has 3. 10 to the power of n must have n plus 1 digits. Therefore, 10 to the power of 77.81 has 78 digits. Next, let's find the leading digit of this number. First of all, 10 to the power of 77.81 can be expressed as 10 to the power of 77 times 10 to the power of 0.81. This part is simply 1 with 77 zeros. So this is the part that determines the leading digit. So for the rest of this question, we can ignore the first part. Recall from the first part, 6 is about 10 to the power of 0.7781. So this number is bigger than 6. Next, let's consider 8. 8 is 2 cubed, which is 10 to the power of 0.3010 times 3, which is 10 to the power of 0.3090. This is greater than this number. Therefore, this number is smaller than 8. Now, what is the distance between this number and this number? The distance between these two numbers is 0.1249. So we would expect 7 to be around 10 to the power of 0.9030 minus 0.1249 over 2, which is about 0.84. So this should be smaller than 7, which means that the leading digit must be 6. So the answer is 6. Section 2. So in this question, we have a function with two variables, and both m and n are natural numbers, and the function I is defined inductively. Number 1 is the base case, and number 2 expresses the inductive step. And in question 1, we need to find I of 2, n, as well as I of 3, n. So let's begin with a very simple case, I of 2, 2, and let's see what happens. I of 2, 2 can be expressed as I of 1 plus 1, 1 plus 1. So using the second rule, this can be divided into two parts. I of 2, 1 plus I of 1, 2. And from the first rule, we know that if either of the arguments is 1, the output is going to be 1. So this is 1 and this is also 1. So 1 plus 1, which is 2. Next, let's consider 2, 3. This is 1 plus 1, 2 plus 1. We know that I of 2, 2 is 2. I of 1, 3 is 1. So 2, 3 is 3. Let's do one more example. So as you can see, the output is always the same as the value of n. Therefore, I of 2, n is n. So let's consider I of 3, 2. 2 plus 1, 1 plus 1. I of 3, 1 plus I of 2, 2. From the first rule, we know that this is 1, and from the previous part, we know that 2, 2 is 2. So 3, 2 is 3. How about 3, 3? 3, 2 is 3, and 2, 3 is 3. So this is 6. 3, 3 is 6, and 2, 4 is 4. This is 10. So the outputs can be expressed as a sequence. The previous term is 3 minus 2, which is 1. 1 is just 1. 3 is 1 plus 2. 6 is 1 plus 2 plus 3. And 5 is 1 plus 2 plus 3 plus 4. So this is the sum of all natural numbers up to n, which can be expressed as n times n plus 1 over 2. Therefore, I of 3, n is n times n plus 1 over 2. And in question 2, we need to find the value of I of 5, 3. I of 5, 3 is I of 4 plus 1, 2 plus 1. So we need to figure out what these two terms evaluate to. I of 5, 1 is 1, but we don't know what I of 4, 2 is. So let's do 4, 2. 4, 1 is 1, and what is 3, 2? When n is 2, 2 times 3 is 6. 6 divided by 2 is 3. So this is 4. And what is 4, 3? 4, 2 is 4. And what is 3, 3? When n is 3, 3 times 4, 12, divided by 2, 6. So 5, 3 is 5 plus 10, which is 15. And this is the answer. Section 3. In question 1, we need to sort the derivatives of these functions in ascending order when x is negative. So let's differentiate each of these functions first. When n is negative, e is very close to 0, but greater than 0. 1 is a constant, and 1 plus x is a linear function, and when x is negative, this will also be negative. Ascending order means that we need to start with the smallest one, h dash of x, f dash of x, and then the biggest one is g dash of x. And this is the answer to the first question. In the second question, we need to sort the original functions in ascending order when x is negative. When x is negative, this is very close to 0, but still above the x-axis. When x is negative, this will also be negative. What does the graph of h look like? So this function has no real roots, which means that the graph will always be above the x-axis. G of x is the smallest, followed by f of x, and the biggest one is h of x. And this is the answer to the second question. In question 3, we need to perform these two integrations. So before we begin, let's see what happens to these two functions at these two values. F of 0 is 1, and f of minus 1 is e to the power of minus 1, 1 over e. G of 0 is 1, g of minus 1 is 0. 1 minus 1 is 0, 1 over e minus 0 is 1 over e. So within this domain, the area will never be negative, so we can basically ignore the absolute value sign and perform the integration as per normal. So the answer to the first part is 1/2 minus 1 over e. And let's think about the second integral. F of 0 is 1. F of minus 1 is 1 over e. H of 0 is 1. H of minus 1 is 1 over 2. 1 minus 1 is 0. 1 over e minus 1/2 will be a negative number. So this integral will compute a negative area, which means that we need to remember to flip the sign at the end. And remember that this area is negative, so we need to put a minus sign in front of it. So the answer is 1 over e minus 1 over 3. And these are the final answers. This is the end of this exam paper. Let me know if you have any questions, and see you next time.